Right, I'm Sarah.
I'm Joey.
And this is our presentation on creative synthesis and sampling. Right, for the assignment brief, it said, I've applied for a job at a well-known musical instrument manufacturing company as a member of the sales team, being asked to attend an interview. Company are looking for someone who will be able to convince retailers to stock their synthesizers and sample hardware and software. In my interview, you need to demonstrate how your expertise in both programming sounds and underlying theory of synthesizers and sample functionality. So, yeah, I should want to do that one.
Sound synthesis is the technique of generating original sound using electronic hardware or software and creating something from scratch. The most common use of synthesis in music is where electronic instruments, synthesizers, are used in the performance and recording of music. Many people use synthesizers in the modern technological world tend not to be educated in the basics of different kinds of synthesis. With the rapid development of music technology and the ease of computer-based synthesis, any synthesis program could be opened and experimented with, but to break the mould in the use of synthesizers in the modern world, you have to be skilled or lucky. This is exactly why it's important for people experimenting with synthesizers to understand the fundamentals and different types of synthesis.
Right, so subtractive synthesis. Creating your own synthesizer patch is the first step towards creating your own signature sound. Subtractive synthesis is one of the main types of synthesis. As the name implies, tones are made by taking away unwanted frequencies to the sound that you're looking to create. The process of subtracting synthesis is as simple as taking away parts to reveal something wonderful. These are a few key components to any subtractive synthesizer. So you've got, oscillator, the filter, the amp and the LFO. These elements are the key attributes of the sound that you're looking to produce. Once you understand each one of these parts, building a new patch becomes a lot easier.
Oscillator. Right, so oscillators produce the original sound which you can hear in the synthesizer's patches, which is then fed through the rest of a signal path in the synthesizer. Oscillation itself is the production of a certain type of waveform which produces a different sound depending on the shape of the waveform. The waveform is constantly run depending on the speed/pitch of the note. Common oscillator waveforms are...
So then you've got, your saw wave, which, for example...
So wait,
let me just... So... saw wave, they all sound differently. So the saw wave, it's shaped like teeth or a saw blade. This produces a very common sharp biting tone. So, that one. And then... square wave, put that on. Sounds very different to the other one. It looks like a near perfect square and produces a really sort of hollow sound. Then you've got, pulse wave, which is a variation of the two above. The pulse wave is half as wide as the square wave and has the ability to have its width modulated, which is called pulse width modulation. Then you've got triangle wave, which is like that. Unsurprisingly shaped like a triangle, this sounds somewhere in between a saw and a sine wave. And then you've got sine wave, which is a smooth rising and falling shaped like a horizontal S. This produces a mild soft tone, so that's like that one. And then just noise, it's not exactly a waveform, but a source of sound produced by a certain colour of noise.
That's noise.
So, yeah, like that.
What does the filter do? By passing the sound through a VCF or a voltage controlled filter, you carve out unwanted frequencies from the raw material sound. There are a few different kinds of filters, but most seem to rely on two key ones: a low pass filter or an LPF and a high pass filter, HPF. The low pass filter allows the low frequencies to pass through, cutting off high frequencies and creating bass sounds. The high pass filter does the opposite, turning the cut-off knob shifts the point at which the filter starts to act on the sound. A filter does not just stop the sound abruptly, it slopes down from the original volume. The slope is measured in decibels, or dB, per octave, which is why you might see a minus 12 dB or a minus 24 dB filter on a synthesizer. The higher the number, the steeper the slope and the stronger the filter. Along with the cut-off, the other key part of a filter is resonance. Most filters have resonance or Q control. Resonance occurs when the sound is from the same range as the cut-off frequency is routed back to the filter, creating feedback. At very high levels, this feedback can cause the filter to self-oscillate and generate a sine wave. Turning up the resonance results in brighter and harsher tones around the cut-off frequency and can be used for a range of techniques including to squeal the synth or to create a classic wah effect as seen on guitars.
Right, and then you've got the amp. So the next step in this chain is the amplifier, also known as a voltage control amplifier. Obviously, this controls the volume of the sound. Most VCA sections also have a volume envelope. This develops a tone shaping the waveform to create the sound that you're looking for. Envelopes are broken into 4 parts. So you've got the attack, which is the amount of time it takes for the envelope to reach the end of the first stage, like usually at the peak level. And you've got the decay. The amount of time it takes for the envelope to decrease to some specific level. Then you've got sustain, the level of output while a sustain introduction persists, like a held note. It's important to observe that sustain parameters is a measure of level, not time. This stage can be theoretically last Then release, the time it takes for the output to decrease to 0 after the key is pressed down, sound's gone.
LFO, because synthesizers were initially keyboard based, musicians couldn't add vibrato to synth sounds by wiggling their fingers, but vibrato was too useful a musical technique to go without. So synths were equipped with a form of vibrato. The pitch of a synth oscillators can be modulated by a signal from a special low frequency oscillator, which is LFO. LFOs quickly proved useful for synthesis technique in addition to vibrato. To date, all synthesizers, most other electronic instruments and many other processors have LFOs. High-end instruments may give you 4 or more LFOs, and let you route their outputs to a variety of synthesis parameters so that the sounds can be animated in complex ways. And I'm going to say LFO one more time, LFO.
So then, just a brief sort of thing of what sampling is. In music, sampling is the act of taking a portion or sample of one sound recording and reusing it as an instrument or an element of a new recording. It's typically done with a sampler, which can be a piece of hardware or a computer program on a digital computer.
The difference between a hardware synth and a software synth. A hardware synth is an actual physical instrument, as you can see in front, that can be touched, unlike a software synth that is all done on a computer. Obviously, being an actual physical thing, a hardware synth has more appeal to someone who is more hands-on with their work. However, a software synth, is more of a hardcore musician who prefers to do it all digitally. Doing it digitally can make it easier for a musician, as a hardware synth can lead to people making mistakes, having to re-record parts. The example of software is Logic Pro, and the examples of hardware are these, which can do things like this. Here we go!
Right, programming sounds. So synthesizers intrigue a lot of people, but all the controls and that they can seem very confusing. The basic information on programming sound into a synthesizer, just sort of give you a basic overview and stuff. So choosing your synth, I highly recommend you start using a simple synthesizer. So a subtractive synthesizer. For the demonstration, we'll be using the Roland SPD-SX. So now we have all the synthesizer fundamentals that I've mentioned before in the other slides. You can just start experimenting with things like that. So yeah, do you wanna get on to what Right, there you go. So these are some the pros of using the Roland SPD-FX, the drum machine that I've just showed you. It's got a unique sampling pad concept. It's the only one of its type. It's got a huge memory, enabling approximately 720 minutes of sampling without any external memory things needed. It's got 9 rubber faces on it, which you hit to trigger sounds. It's easy capturing of audio and stuff through the multi-pad sampling bit. Yeah, so then performance, expanded USB functionality, like a large like backlit LCD and all that as well.
Different types of synthesis. Additive synthesizers. Additive synthesis refers to a number of related synthesis techniques, all based on the idea that complex tones can be created by the addition of simpler tones. Wavetable or wavetable synthesis is a technique used in the certain digital music synthesizers to produce natural sound. The sound of an existing instrument is sampled and analysed into a sequence of samples or wavetables. Frequency modulation synthesis, or FM synthesis, is a form of sound synthesis where the frequency of a waveform, called the carrier, is changed by modulating its frequency with a modulator.
So these are just some of like the common sampling techniques that people can use. So you've got trimming, that's such a way you get trips, and you can top and tail and then like take bits out that you don't want. Reverse, obviously that would be selecting the audio that you want, and you can like play it backwards. Crossfades, in digital audio production, a crossfade is like editing that makes like a smooth transition between like two separate audio files. Crossfading became easier to achieve with the invention of like computer-based like digital audio editors and things like that. This edit consists of fading out one source or like fading another one in at the same time. This creates like a smooth transition for like a short period of time, which is like better for the listener. And then like loops, that's a loop can be created by using a wide range of musical like technologies, including like turntables, digital samplers, synthesizers, sequencers, drum machines, etc. Or they can be like programmed using a computer music software. Just some more techniques like you've got slicing, like beat slicing. Is a process of like using like computer programs to like slice up audio files into like smaller sections so you can like leave more of what to do with them. Then you've got like things like layering as well, which is like different sort of instruments like occupying a similar or slightly different frequency in the spectrum. Like layering in general means to use like a couple different of like sim sounds together to create sort of like more sort of like thicker sounds. And then like time stretching, which is the process of changing the speed or duration of like an audio signal without affecting like the pitch of it or distorting it. So yep. That's it, cheers.